Hey everybody, welcome to my talk. Let me get started. I'll be chatting a little bit about scaling your service on what matters, which, spoiler, I'm going to claim is latency. But before we get started, since I'm going to be talking about autoscaling, if my slide moves forward here, I have got an application up that I'm hoping everyone is going to DOS me on. I'll just show it here while I'm waiting. Please vote on what the best editor in the world is. I might have gamed this. I'm expecting everybody to vote only for Emacs. Actually, I'm a little sad that the votes are going the way they are. But please, this is actually the live app that we're going to be autoscaling here. What's the address? I've got it on a slide. Just give it a second here. Ha, there we go. But first, before we get started, now that I've introduced the app, let me tell you a little bit about myself. My name's Thomas Rampelberg. I'm a software engineer at Buoyant. And what that means is that I'm spoiled rotten because I get to work on open source all day, every day, and contribute to Linkerd, which is going to be part of this talk. If anyone's remotely interested in hearing rants about pretty much anything in the world, follow me on Twitter. My Twitter handle is up there. And here we go. kc.l5d.io, please go get your votes in. If anyone wants to try and DOS this, I'm very excited. So now that we've got that introduced, I'd like to talk a little bit about what autoscaling is in Kubernetes, because it's actually a little complex. There's three major types of autoscaling in Kubernetes. One is the cluster autoscaler. That goes and creates new nodes for you and grows and shrinks the pool based off of the request limits on your pods and containers. Basically, if you run out of resources, Kubernetes can't schedule something, your cloud provider will go create you new nodes. What this talk is going to be about is the horizontal pod autoscaler. That goes and takes a metric, by default the CPU and memory, and adjusts the replicas for you to go and increase the number of replicas on your deployments, for example. Then we have the vertical pod autoscaler, which goes and does that vertically instead of horizontally. It'll go monitor the CPU and memory usage and adjust your resource limits so that your pod fits in it. This actually solves an awesome problem of it's really hard to figure out what the limits and resource requests are supposed to be, and this will help you do that. But let's talk a little bit about what horizontal pod autoscaler is and where it gets the metrics. What's up? Oh, the screen is jumping up and down. Crazy. Well, we'll just continue on, and I apologize. Okay, so three types of metrics in the Kubernetes API. Number one is the metric server, or the metrics API. That is works off of the metrics server, which is now integrated into the kubelet, and that gets you all of your system metrics that you would expect. That's CPU and memory, free out of the box. It's a really great way to start doing monitoring on your cluster. We then have the custom metrics API. That's what I'm going to be talking about. And that goes and lets you do it on any metric that you want. Obviously, we're going to be taking a look at latency today. And then you've got external metrics, which is something external to a pod or a namespace. So this could be the ingress that you have, or since we're doing a talk on autoscaling, imagine a cron job that goes and sets a bit to autoscale when you have a flash sale about to happen. So now you can go and do scheduled autoscaling, which is pretty awesome. So let me get started with why CPU is not necessarily what you want to do. The first obvious one is not every workload is CPU bound. You really have to figure out what your workload is. Sometimes it's I/O bound, sometimes it's memory bound. You really have to guess. The biggest thing for me, though, is to autoscale, you have to put the threshold below 100%. So you have to say, OK, I'll autoscale, but it will only be at 90%, which means that you now have 10% unused capacity in your cluster. Isn't autoscaling all about being cheap and getting the best use out of your resources? Another good reason, CPUs are different. I'm sure all of us have experienced it. Depending on a region, depending on your instance type, depending on your cloud provider, a CPU is kind of a random guess as to whether you're going to get good performance or not. And then probably the biggest thing for me is that orchestrated environments are super complex. Imagine having someone schedule a big data job right next to your service. That's going to destroy the disk, it's going to kill the CPU, and even though you're using your resources correctly, your response times are going to go out the window. And so you really need to have a way to look at it. Since I'm a bit of a CPU utilization geek, I actually have two notes at the bottom of this. One of them is CPU utilization is wrong. It's written by Brendan Gregg, and he actually explains CPU utilization really is an approximation, and you need to think about it a little bit more complexly. The other one is by Adrian Cockford, and he claims utilization is completely useless as a metric. So those are two good reasons to think through why the out-of-the-box CPU is not necessarily the thing that you should be using to autoscale on. So then let's talk a little bit about memory. Memory is actually great, but it's super duper specific about your workload. Autoscale on memory for Memcache, of course. Redis, of course. But your normal API service, it's probably not going to work. So I've thrown out the normal monitoring. What can you actually scale on? Let's talk about what you should be monitoring for your services. The Google SRE handbook talks a lot about the golden signals. And these 4 golden signals are what they claim are the only things that you absolutely need to monitor on your service. Sure, you can implement other ones, but these are the 4 that they say are the most important. We have latency, which is the time that a customer requires to get a response. There is traffic, the requests per second that are going through. There are errors. This is the number of 500s, for example, that you're returning, or unknown if you're in the gRPC world. And then there is saturation, at which point the service degrades so heavily just because you've saturated it, you need to track these 4 things. And I've got a link there to the page actually in the book if anyone is interested. So we're talking about latency. I've kind of said, obviously you should be measuring latency. Why don't we use that as a way to do autoscaling? The other thing to think about, and this actually blew my mind when I found it, the link at the bottom is to an article called Everything You Know About Latency is Wrong. Tail latency is super important. In fact, I've got a chart here on the right that is the number of requests for popular websites. There are 190 requests fired off when you load Amazon.com. If you're looking at a P99, which is the 99th percentile latency, what that means is we've thrown out the 99 fastest latency measurements and take the 1 slowest. You have an 85% chance of having your customer on a single load of Amazon.com hit your P99 latency. So they're going to have a bad experience 85% of the time. You've got Google, and that's just the basic Google search page. You're guaranteed 25% of the time to hit a P99 latency on at least one of those requests. The users see responses. They don't see your CPU. So that's what they're going to be judging your service on. And latency is not actually normally distributed. It's kind of random. You need to go figure it out. So here is a little bit of a background on what I'm going to be doing from a live demo perspective. I'm going to show you measuring the latency of a service. We're going to expose the custom metrics, and then we're going to do some auto-scaling. To talk about how to measure the latency of a service, though, I'd like to talk a little bit about Linkerd. And the reason for that is, how many of you here, actually, I'm interested, have latency-based monitoring on their services today? That's pretty awesome. Is it for all of the applications in your organization or just at the ingress? Anyways, it's kind of hard. I've done the instrumentation. You have to go figure out Prometheus. You have to go hook it up. It takes a while. So I've got the world's simplest Python application serving up the leaderboard that I hope you all are still voting for. And Linkerd is going to be used to instrument it. So what is Linkerd? Linkerd is an open source service mesh. It's a CNCF member project used in production with quite a few people. But that doesn't really explain what it is or why you need it. So at its most basic, Linkerd is nothing more than a proxy that gets scheduled alongside your application. Because of the magic of IP tables, it receives all of the incoming traffic and all of the outgoing traffic. And because it's at layer 7, we can go and instrument all of the requests and the responses. This isn't TCP traffic. This is actually what requests are and how long responses take. But that's only half of the picture. To do a full monitoring setup, you actually need a control plane to go along with your data plane. So we ship with Grafana dashboards and Prometheus out of the box. So with a single install that I'm about to show you, you get the latency and all of the 4 golden signals immediately for your services really quite quickly. So let's go do that. So I've downloaded the Linkerd CLI onto my laptop already. But we provide this thing called Linkerd check, which will pre-flight and post-flight your cluster. I have gone and installed so many Kubernetes packages on my cluster, and they work half the time, sometimes-ish. I'm not usually sure. And so here we go with a tool that tells you, OK, you have all of the permissions, you're ready to go. At which point you can type Linkerd install. That outputs the YAML that you can then pipe through kubectl. The reason why we do this is that you now can go validate this before you pass it into kubectl. There's nothing magical happening on your cluster. You're not curl bashing something. So we'll put that onto our cluster here. And while the internet gods smile on me, I hope. There we go. What we'll see is we're just applying all of the things that I explained for the control plane. This is the Prometheus, the Grafana. We have a web dashboard that ships and a couple other things. And then once this is done, we also have a Linkerd check command for post-flighting. And this is actually going to hang up because it hasn't started the containers yet. We'll come back to this. But this is a way to validate that your install was successful and is actually working. So you don't need to go debug weird edge cases. So now, that's the control plane. It's going to be up and running, I promise. Let's talk a little bit about the data plane and getting it into my application. What you want to do there is inject the Linkerd sidecar proxy and init container into your application. You could go get your YAML and do it, but I'm really lazy. And I'm just going to get the YAML from the Kubernetes API server and pipe that through. So here I am getting the YAML, and then I'm just going to inject. And here you'll see if I scroll up a little bit, we've got the IP tables init container, and we have the proxy injected. We've also done the pre- and post-flight checks on the data layer as well as the control plane, so you can validate that your YAML is correctly formed. It doesn't have any weird configuration. It's ready to go. So if we pipe that on through, this is going to do a rolling deploy of my application. I hope people are loading it, because I'm excited to see if it stays up. And if we do a Linkerd check, we'll make sure that the control plane is up and running, which it is. And then if we do a Linkerd check proxy, we'll see that that container is still rolling, but it will be up soon. In fact, it just came up. So now let's go take a look at the dashboard. And get a feel for what's actually happening on our cluster. So here you'll see that we're actually doing about 500 RPS. I have a load generator that I added that's already doing 1,000 RPS. And you'll see that our P99 latency is 3 milliseconds. So let's open up the Grafana dashboard to have it there to be a reference. Nice. 1,300 RPS is where it's at. Cool. OK. So I've showed you how to measure the latency of a service. Now it's time to talk a little bit about what it takes to expose the custom metrics for Kubernetes. Back in the heady days of 2017, when Kubernetes was young and a small project, the team spent quite a bit of time trying to figure out how to extend the API. So pre-CRDs, they introduced this idea of the API server as an aggregator. The API server being the single place that you want to talk to figure out all of your data. And to do that, what they did is introduced an API service object. So I've got the resource up here. And basically, this is just saying, I would like to proxy everything to the custom metrics API back to a Prometheus adapter, which is about what I'm going to show you right now. So here's the Prometheus adapter. It takes the custom metrics API, and literally just translates it into Prometheus queries. So I've got the API at the top, and I have the Prometheus query that we are translating to in the bottom. And so you can almost think of this as just a simple translator. It's going to run one pod on our cluster and be ready to go that way. So here is kind of an architecture. It's fun to talk about this and show how all of the Kubernetes components actually work together. So here we've got a kubectl calling the API server. That's going to be calling the custom metrics API, which is going to get proxied back to the Prometheus Adapter, which is then going to hit Prometheus for a query. Really pretty simple. So why don't I show you how to do that? So if we go back here, I'm going to be using Helm to do this. There's a stable Prometheus Adapter package that's absolutely fantastic. And let me show you a little bit of what it requires for me to actually configure that. So here I have, pretty simple, I tell it where my Prometheus is, and I've configured 3 queries. I've got a 50th percentile, a 95th percentile, and a 99th percentile. Out of the box, they actually have quite a few more metrics. I've stripped this down for the demo so that we don't get overwhelmed with the sheer number of awesome metrics that you can get out of this. So to get it installed, I'll do a Helm install here. And pass in my configuration. That's going to render some templates, get them applied to the cluster. If I scroll up here, you'll see that there is an API service that's been added. So that's going to be what tells the Kubernetes API to proxy it back to the Prometheus Adapter, and a couple other things, including a command. So before I run that, let's go take a look at what the application is doing through the Linkerd CLI. And so here we've got, looks like we're doing about 1,200 RPS right now with an interesting latency of 73 milliseconds. This is going to be pretty exciting. So let me show you now what the custom metrics API looks like. And because I don't like to remember this one, here we've got a query. You'll see the route right here. We go and say, tell us all of your metrics. And if we look through this, we've got the pod's 50th percentile latency. I promised that the 99th, there it is, right there. And then I've got this other query here that's going to go and say, tell me all of your values. And you'll see that it's this insanely large value. Remember that Prometheus, to avoid any kind, remember that Kubernetes, to avoid any kind of floating point math, multiplies everything times 1,000. And so this is basically, what is that, 20 milliseconds, give or take? And that's pretty much it. I've now exposed my metrics. So we're now measuring the latency of our service just by injecting Linkerd into our data plane. No code changes, nothing special happened there. I'm exposing the custom metrics through the API service, through the Prometheus Adapter. And now let's actually talk about doing the autoscaling. And to do that, let's talk about what the horizontal pod autoscaler does for real. So what it does is every 30 seconds, as a controller on your Kubernetes cluster, it queries the API server. That's it. It's so simple. It's awesome. So it queries the API server every 30 seconds. That eventually gets proxied back to our applications that have been fed up into Prometheus. And if your stat is out of its range, well, it'll autoscale it for you. The algorithm is pretty simple. I recommend anybody go look at the documentation if you're interested. The whole thing is just kind of simple. It's really nice. So let's go do some autoscaling. And to do that, what I'm going to do is first show you what the policy looks like. So here we have a HPA resource. And I'm saying I want a min replicas of 1, max of 100, and target 8 milliseconds. I'm going to apply this, and we're going to see some autoscaling happening. So while that is doing its thing, let's go take a look at the Linkerd CLI again. take a look at what our latencies are. Ooh, oh boy, you guys are really killing me. This is awesome. So we're doing, it's pretty obvious this needs to get auto-scaled at this point right away. There's no question. But I bet you that we're actually already doing that. So if we go do a kubectl describe on the web HPA, excuse me, we'll see that it's already scaled my pods up, and the response latency is way out of the range of possibility. And so if I go over here and do a watch, we'll see that I've got 4 pods that have spun up. It's taking them a little time to get the traffic spread out. But here in just a couple seconds, thank goodness, it didn't make a liar out of me, you'll see that we start to automatically load balance traffic from you guys and my load generator, and immediately start to see the latencies go down. In fact, I'm wondering what's broken on that one pod, because everything else is down in the 1 millisecond range. And if we go over here, you'll notice the request rate is measured, and eventually we're going to have everything normalized there. That's it. But I want to talk a little bit about the cool things that you can do on top of this. And to get started, I want to talk a little bit about route-based scaling. So in the latest version of Linkerd, we added the ability to not just get latency on a service, which is useful, but to get latency on a route-by-route basis. And what that empowers you to do with autoscaling is usually you only have a couple mission-critical API endpoints. Just autoscale on the latency for those, don't do it for the whole service. This is even more optimized than, for example, changing at 100% CPU utilization. And because I think it's an awesome demo, I'm going to show that off just really quick here. In fact, I have the ability to introspect and get a open API, aka Swagger, out of the leaderboard application. And then I'm going to pipe that into the Linkerd CLI that's going to convert it from the open API specification into a CRD that basically is regexes to be matches and handle that. So we pipe this on through to kubectl. And if my cluster hasn't melted down, we just started generating statistics for this, so it will take a couple seconds. But in that time, we could go and have crafted a query for Prometheus, exported it through the custom metrics API, and be able to get all of the metrics for what's going on there. In fact, you'll see here that we're getting the latency. It's slowly shifting over on a per route basis. Wow, that's awesome. And then finally, and this is the one I think maybe I'm actually the most excited about, Prometheus is basically the most amazing thing on Earth, as far as I can tell. And it comes with the ability to do linear regression. So you can actually do predictive autoscaling with this setup on Prometheus. Remember, it takes 30 seconds, 60 seconds for everything to warm up. You can say, I know that my latency is going to be past 8 milliseconds. Let's scale up 60 seconds in advance so that everything is running and ready to go right when we get there. And that's actually it. It's really simple to get going with this. You don't need to stick with CPU and memory in the box. But really quick, because I've thrown so much data at everybody, I've got this final slide here. I've got my slides up on GitHub. It's a PDF. I'd love for everybody to go take a look. I also have the code up to hopefully run this yourself. We have a getting started guide for Linkerd if anyone's remotely interested. Don't worry, you don't need a Kubernetes cluster. We're actually using Katacoda to be able to run a Kubernetes cluster in your browser, run through the whole getting started. And finally, we've got the Prometheus adapter there for everyone to give it a try. And that's it. Thank you so much. So we definitely have some time left. I would love questions, and I just saw a hand raised.
So how does that work if you have, for example, a dependency on another service or database that's pretty slow?
So the question was, what happens if you have a dependency? In fact, my app has a dependency on Redis, and I suspect that the reason why the numbers right now are not what I've tested in the past are because Redis is going a little bit slow. You need to understand autoscaling isn't a silver bullet. You have to really think deeply about what your architecture is and how to scale it. If you're running a microservices architecture, you want autoscaling at all of the different layers, and then you want to go and think how it interacts. While I made it seem super easy, it really is not just a silver bullet. You have to think about your workloads and how it all works together, for better or worse. Any other questions? Yes?
So on a queue-based system where you've got a queue that's doing the work, you want to autoscale when the queue starts backing up or when the utilization starts. Is there any way to know what you've done?
So you wouldn't necessarily need to use Linkerd for that. I would probably use the custom metrics based off of your queue length and just autoscale on that. But it gets to the real power of custom metrics or external metrics. Again, if you've got your Kafka cluster, for example, hosted off Kubernetes, you can go use the external metrics API to do the autoscaling on that. But that gets back to your workload is your workload. You need to kind of think through how it works. This works pretty well for very specific API services, but once you get out of that, you need to kind of figure out where you want to go with that. Any other questions? Yes? So you definitely could do that. The problem is that then you have to think through what your overhead is and really understand what your saturation is. Because I don't actually know what my service here saturates at. It's really hard to say, okay, autoscale, but autoscale at 1,000 RPS. Because who knows, it's going to get scheduled to something different. And so this does, again, kind of get back to it's your own workload, figure it out. But this is kind of the next level of approximation. If you know your saturation layer and you know what CPUs you're scheduled on and you're sure that you're getting all those resources, that is actually a better way to do it. But the amount of information required to get there is so much that taking it a step back, I actually feel that this is a better approximation, but not the best. Anybody else? Yes? So you can, but it would end up being an external metric, and then you need to think through what that means on a pod-by-pod basis, because maybe one pod is going way slow and one pod is going fast. So you definitely can do it. I mean, honestly, technically, you don't need Linkerd for this. If you want to go instrument your app for Prometheus, you can go stand that up for yourself. The power is that you don't have to. It's monitoring, in my experience, is always the thing that falls to the bottom of the priority list. And so you normally have to make this trade-off. Are we going to have some better monitoring so people get paged less? Or is a product manager going to ask to put more features in? And I'm sure you know which way that goes. And so you can really think of Linkerd as just this like easy way to start out. OK, we've got monitoring. It's common. Let's go from there. I saw a hand. Yes? Well, so this comes to how you're doing your deployments, but it's smooth insofar as it's going to be a rolling deployment. And so when the new pod comes up, it will already have the proxy there, and the traffic, once it becomes ready, the traffic will slowly shift over there. So one of the cool things about Linkerd is that it's really focused on being incremental. Having a big bang in production scares the crap out of me. Just do it on one service, just do it for one pod, get really comfortable with it, and then start to expand it out so that you start to get comfortable with the latencies and figure out how all of that works together. Yes?
What kind of endpoints can you monitor? Have HTTP or TLS, HTTP2?
So I'm so glad you asked that. One of the coolest things about Linkerd is that it's gRPC aware. And not just that, but it's gRPC aware from a status code perspective, because every gRPC response is at HTTP 200 OK. And so not only does it do HTTP 1 and 2, it also is aware of gRPC. It doesn't do things like Kafka or Redis or MySQL, some of the other binary protocols. It could be added, but the instrumentation isn't there yet. It really is specific to the family of HTTP protocols and where you go for there today. Cool. Anybody else? Yes? Ooh, that's a good question. I don't know the answer to that. If you come by the Buoyant booth, we'll get somebody to actually answer that. We've just introduced retries and timeouts, and so I think that there's a good answer there, but I don't know for sure off the top of my head. Yes?
I'm not familiar with what Linkerd does as a service mesh, but doesn't it, ideally, eventually, you would want it to be able to do kind of like the certificate tracing where you can see all of the hops that it's making. So, does it do that yet?
So,
Can you just measure just what part of that traffic and then actually have a better metric? Say what latency is happening actually on this service as opposed to the rest of it?
So that's actually what it does. You're teeing me up for a very large rant that I have. I'm going to take a step back. But say the latency is actually getting measured completely depending on where you look in the system. So it is at a pod level, it's at a deploy level, it's at a service level, and so you can slice and dice it all without passing headers on, which is kind of the Achilles heel of most of the distributed tracing. In my experience, most folks want to understand the DAG and the connections between services. They're not actually interested in tracking spans that are specific to a single request. Yes? Yes? I honestly think that the end goal here is to go and create aggregate metrics exactly where you're going, where you don't just autoscale on latency, you actually measure a bunch of the golden signals and potentially CPU and feed that into the horizontal pod autoscaler. So it's totally possible to do. I just didn't happen to show it off here. I think we're out of time. I'm going to hang around here and be back at the Buoyant booth for all of your questions. I would love to answer them. Thank you so much for coming.